Question 7, we've got to differentiate this curve here. And as you can see, we've got a mixture of x and y terms. We haven't got y on its own on the left-hand side of the equation. We've got a mixture of terms, and to find dy dx, we need to employ implicit differentiation and the rules for that. So before we start, almost certainly we're going to be using the chain rule and we're going to be using the product rule for differentiation. So let me just write those two rules down so that we've got them close at hand. So to use implicit differentiation, if we find a term in x, we differentiate it normally. If we find a term in y, we differentiate it as though it was x, but then we have to write dy dx alongside as a multiplying factor. So first term, easy enough. Bring the power down, reduce it by 1, we get 3x squared. Now 2xy is a product, so we're going to have to employ the product rule. Let's say y is v and u is 2x. So we first of all write down v, which is just y, and we differentiate 2x with respect to x, and as x is the normal one, we can just differentiate that to 2. Plus, write down u, which is 2x, and differentiate the y. And as y is not the variable we're actually differentiating to, we can differentiate it as normal, but we must write dy dx. Differential of y differentiates to 1, but I must write dy dx here. Plus, again, we've got a term in y, so we've got to differentiate it as though it was normal, but then write dy dx alongside. This is 6y dy dx, and the 47 differentiates to 0. So I now need to take dy dx out as a factor, and I've got 2x plus 6y. I'm going to put the remaining terms on the other side and making them negative as they move across. So this is negative 3x squared minus 2y. So therefore dy dx is equal to these two divided by 2x plus 6y. And that's the answer to part A. So in part B, we're told that the point P, negative 2, 5, lies on the curve, and we've been asked to find the equation of the normal to the curve at P. So finding the normal to any curve at a certain point involves finding the gradient of the tangent and converting that to a negative reciprocal to find the gradient of the normal, and then as the normal goes through that same point, we can substitute those points into the gradient equation and get an equation for that normal. So we need to first of all find the gradient at the point negative 2, 5. So if we sub x is equal to 2 and y is equal to 5 into our gradient function, we should find the gradient at that point. And if you do the maths, you'll find that dy dx is equal to negative 11 over 13. So therefore, gradient of the normal is the negative reciprocal of this guy. So this is 13 over 11. So now we can use the definition for gradient using our coordinate point and work out the equation. So I can say that y minus 5, the y coordinate of the point, divided by x minus minus 2, which is x plus 2, is equal to this gradient, which is 13 over 11. Cross multiply and get, therefore, 11y minus 55 is equal to 13x plus 26. We can put the numbers together, and they want everything on the left. So this is going to be 11y. The 13x is going to hop sides and become negative 13x. The negative 55 is to be joined by 26, which is now negative, so this is negative 81, and that's equal to 0. And that's the answer to part B.